Hi everyone, my name is Sun Long, and along with my co-authors from Google Cloud, Google DeepMind, and the National University of Singapore, we are presenting our work on VISTA, a test-time self-improving video generation agent. Let's start with our motivation. State-of-the-art text-to-video models are incredibly powerful for storytelling applications and have attracted great community attention. However, these models are highly sensitive to input prompts, struggling with issues like alignment and common sense. And this sensitivity causes humans to spend laborious circles of trial and error and often thousands of dollars just to obtain reasonable video outcome. And prior work has limitations. Prompt optimization methods require whiteboard access or fine-tuning, while existing multi-agent systems focus on orchestration but lack the capability for test-time self-improvement during generation. So our goal is to automate that human trial and error process. We introduce a multi-agent system that allows video models to self-improve video quality at test time. It works through interactive prompt optimization driven by multi-dimensional critics and tournaments. So let's dive into our work, VISTA, which stands for Video Interactive Self-Improvement Agent. In a nutshell, VISTA concurrently optimizes videos across three major categories in a closed loop: visual, audio, and context. Here is a high-level overview of our system, which we'll now break down step by step. Given user input, we first perform a planning step to obtain its prompt variants. We then generate videos based on these variants and select the best one based on a robust selection process. The selected video is then input into a multi-agent system to obtain feedback, and the feedback is then used to optimize the prompt. The optimized prompt advances to the next iteration. So let's dive into step 1. Single sentence prompts fail to reflect real world complexity. Our solution is to plan the prompts structurally and carefully. We convert the user prompt into multiple prompt variants, each defined by 9 properties like duration, characters, and so on, to enforce quality and detail constraints. We then generate videos based on these prompt variants. So, step 2 is about comparing these videos. The challenge here is how can we obtain human-like and reliable video comparisons, as comparing videos is challenging. Our solution is to use binary tournament combined with probing critics. After obtaining winning video, we execute the multi-dimensional multi-agent critics to obtain video feedback. We critique three major dimensions for comprehensive video evaluation, which are visual, audio, and context. And to obtain comprehensive evaluation, we perform a novel process inspired by the jury process. After obtaining the feedback, we perform a 6-step self-refining process to optimize video prompt, and this structured approach, divided into review, diagnose, and refine phases, ensure prompt optimizations are precise, effective, and avoid unnecessary complexity. So now let's move on our experiments. We experimented with both single and multi-scene scenarios. We evaluate based on B-bench and LM search. We compare VISTA with standard and scale baselines. Looking at the results on single scene benchmark, we find that standard baselines show only marginal, inconsistent, and often unfavorable win-loss ratios compared to direct prompting. In contrast, Vista demonstrates clear, consistent benefits with more optimization iterations. We find that Vista improves the most on visual fidelity, audio quality, alignment, and engagement. So to conclude, we introduce Vista, a video test time self-improvement agent. Vista equips a novel self-improving capability for video models, generalized to multiple video models, and improve user preferences. We invite you to visit our project page and paper for more interesting insights and limitation discussions. Thank you.